Alright, so new topic today. We're going to talk about Riemann sums. This is a way to estimate the area underneath the curve. Last time we talked about integration, we started to talk about integration. This is a way that we can quickly do an estimate for integration in your head. So our objective is to estimate the area underneath the curve using rectangles with heights from the left, from the right, or from the middle, or trapezoids. Okay, so here's what it looks like. Here I've got a function y equals 1/4 x squared. X squared over 4. And I've got my interval from x equals 0 to x equals 6. Okay, what I'm doing is I'm splitting this up into equally spaced rectangles, so 6 of them in this case. So each one of these rectangles has a base of 1. So base of 1, and then a height of whatever its function is on the left. So this first rectangle, if I plug in x equals 0, is 0. So that's 0 times 1 is 0. Okay, for my second rectangle, I still have a base of 1, but my height is now what happens when I plug in 1. So this is 1 squared divided by 4 is 1/4 times 1 is 1/4. Okay, and I would keep doing that for each of these rectangles, so getting the base and the height for the left side. Okay, I'll do this. We'll mark with lines. 1, 2, 3. Okay, once you've got all of your areas of each rectangle, then you add the areas together. So this was no area, 1/4, 1, 9/4, 4, and 25/4. You add them all together and I get 13 3/4, or 13.75. Any questions on what we did? Okay, so a left-endpoint Riemann sum means we're getting the heights of each of these rectangles from the left side of each of these bases. So here for this base between 0 and 1, you could have picked 0 if you wanted to go from the left, or 1 if you wanted to pick from the right. With a left Riemann sum, as long as our function is increasing, if f of x increases, then a left-endpoint Riemann sum will underestimate the area. Okay, our function will underestimate, and if our function is decreasing, we will overestimate. Okay, here's heights from the left side again. You can see that we are over the curve. Okay, if I didn't want to go from the left, we could go from the right instead. So you'll notice the heights of each of these rectangles are taken from the right side of that interval, not the left side this time. So from 1 to 2, or from 0 to 1, I would take my height at 1. From 1 to 2, I would take my height at 2. From 2 to 3, I would take my height at 3. I'm taking my heights from the right-hand side. Okay, let me do the same thing. Just get the areas of each of those rectangles using base times height. So my base again is 1 for each of these. If I'm going to split 6 rectangles out of my distance from 0 to 6, then each one should have a base of 1. And then we'll plug in all of your x values into your function, which was y equals x squared over 4 in this case, in order to get your y values. So my first rectangle is 1 squared divided by 4 is 1/4 times my base of 1 is 1/4. Second rectangle would be 2 squared over 4 is 1 times 1 for my base is 1. And I keep doing that for all of my rectangles. Okay, any questions so far? Okay. If I wanted to get heights from the middle, we can do that too. So getting heights from the middle means we'll take our average of our two sides. So this first rectangle has a base of 1, but it has possible heights at 0 or 1. So I'm going to take my average between them to get my x value at 0.5 and then plug that into my y value. So my first rectangle would be for my y value, y at my average of 0 and 1, which is y at 0.5, or 1/2 squared divided by 4 is 1/16. Times 1 gives me 1/16 for my total area here. Okay, and I keep adding all of those areas together until I get my final answer. So this one is 121 over 16, 81 over 16, 49 over 16, 25 over 16, 9 over 16, and this one is 1 over 16. Okay, we add them all up. Since they're all over 16, I can just add the tops. If I add all of the tops, I get 286. So that's 286 over 16, or 17.875. Okay, so midpoint Riemann sums, we're taking our heights of each rectangle from the middle of our change in x's. Okay, and the last one. I guess I didn't make a slide, so I'm going to jump in. Last one is a trapezoidal Riemann sum.
Is there any shortcuts, or do we always need to like do it, and add all together?
Let me go back. So as long as your bases are the same, so in this case all my bases are 1, I could pull out 1 from all of those and just multiply by your heights, which might be a shortcut depending on what you're doing. But I do still need to go through and get the areas for all of these rectangles and add them together.
Okay.
Okay. So we got a problem with displaying this one when I opened that last time, so I'm going to see if I can pull from a previous year. Oh, still a problem with display. There we go. Okay, so if I wanted a better estimate than just using rectangles, we could use trapezoids instead. That trapezoidal Riemann sum will take the heights from both sides. So the area of a trapezoid is your average of your heights times your base. So for this one, my base is still 1 for all of these trapezoids. But instead of just using one height, I'm going to use both. So effectively what that does is that gives us a rectangle and a triangle that we can use to estimate our area underneath the curve, which ends up being a much better estimate than just using rectangles. So for this one, I would take my height at 0 and my height at 1 and divide by 2 to get my average, then multiply by my base of 1. Okay, if we do that for all of these, then I'll end up with 73 over 4. Okay, just to see how close this is. Our function was y equals x squared over 4. If we integrate, like what we did for the homework, x squared over 4 in terms of x, I'll get x cubed over 12. So if I wanted to figure out how much the area changed from x equals 0 to x equals 6, what's the area underneath the curve from 6 to 0? I would get 6 cubed, which I believe is 128. Oh well. 6 cubed over 6 times 2 minus 0 over 12. Okay, 1 6 will cancel, so this is 36 over 2, or 18. Is my exact area underneath the curve. See, our estimate's pretty close. 4 by 20 is 80. So we've got like 18 and 1/4 here. We're pretty close with our trapezoidal sum if you want to do a quicker estimate. So these Riemann sums are useful when we're making estimates and an integral is going to take a really long time, or when we don't have a function, so I can't do my exact estimate, and we have to use just data points. Okay, so I'm going to look at a couple examples really quick. Here I've got a left-hand Riemann sum that I'm using to estimate values from the table. So you can see my heights are taken from the left side of each of these bases, but my bases are now not all the same. So this change in x from here to here was only one value, but this change in x from here to here was 2, 1, and 6, right? So if I wanted to get the areas of these rectangles, this would be my change in x, so that's 1 times my left side, or 1 times 4 for my first rectangle. Okay, and the same thing over here. So I have a change in x of 2 units from 1 to 3. So that's 2 times my height of 2, plus my next change in x from 3 to 4 is 1 times my height of 3, plus my next change in x of 6 times my height of 2. Okay, any questions on what we did?
No.
Okay, here it is graphically again. So 1 times 4 is 4 units here. 2 times 2 is 4 units again. 1 times 3 is 3 units here. And then 6 times 2 is 12 units here. And I can add all those together to get my left-hand Riemann sum. So I could say my sum, or my area, is 4 plus 4 plus 3 plus 12. So that's 15, 19, 23. Okay, if I wanted to do a right-hand Riemann sum, I would take my heights from the right-hand side of each of these intervals. So here's my first interval is 2 units. My right-hand side is -2, so this is 2 times -2 for my first one, plus an interval of 4 times my right-hand side of -1, 4 times -1, an interval of 2 times my right-hand side of 0, an interval of 1 times my right-hand side of 1. Should equal my area estimate. Okay, here it is graphically. I've got a rectangle with -4 area, another rectangle with -4 area, a rectangle with 0 area, which we don't have to graph, and the next rectangle with 1 area. If we add all that together, I've got -4 minus 4 plus 1, or -7 for my area. Okay, so the key here is I will give you whether you're looking for a left-hand or a right-hand Riemann sum. If you've got a left-hand Riemann sum, use your heights from the left. If you've got a right-hand Riemann sum, use your heights from the right. If it's a midpoint, you'll need to take an average. And if it's a trapezoid, you'll be using both. So here's one more, last one for today. I've got our function, x squared over 2 plus x plus 1, from -5 to 3. And I want to break this up into 4 equally spaced trapezoids, 4 midpoint rectangles, 4 right-endpoint rectangles, and 4 left-endpoint rectangles. So to do my left-endpoint rectangles first, graphically would look like this. So we've got 1, 2, 3, 4 rectangles is the goal. That means since I've got 8 units from my start to finish, that each rectangle should have a base of 2 this time. And then I'm going to take my heights from the left. So this is 2 times the 8.5, 2 times the 2.5, 2 times the 0.5, and 2 times the 2.5. Or here, 2 times 8.5 is my first rectangle. 2 times the 2.5, 2 times the 0.5, 2 times the 2.5. When I add them all together, 2 times 8.5 is 17, plus 5 plus 1 plus 5 is 11 plus 17, or 28. Okay. Any questions on what we did for the left Riemann sum?
Wait, why are we skipping the? Are we skipping the evens because we're doing the left?
We're skipping the evens because they asked us to use 4 rectangles, not 8 rectangles. So if there's going to be 4 rectangles, they're going to be evenly spaced. Then my first interval is going to be between -5 and -3. There's 8 units, so each base should be 2 units long.
So to determine like which numbers should we choose, we must look at the most right hand side number, right?
So to figure out which values you're going to use for your x values, I'm going to take my start minus my finish. So my change in x is equal to the difference between the starting value and the ending value, so that's b minus a, divided by n, where n is your number of rectangles. Point A is start point. N is number of rectangles. So here graphically, if I want to take this distance from x equals -5 to x equals +3, and split it up into 4 equally spaced rectangles, that's a distance of 8. So 3 minus -5 is 8. 8 divided by 4 is 2. So each one of these change in x's should have a base of 2, which you can see on the graph.
Okay.
Because this is a left-endpoint Riemann sum, the height of this first rectangle should come from the left side. So that's starting at -5.
Because it's what?
This is a left-endpoint Riemann sum, so that means your heights will come from the left side of each rectangle. So this
So
first
from the negatives.
from this first rectangle, which goes from x equals -5 to x equals -3, the height of that rectangle will come from the left side, because this is a left Riemann sum. So that left side is x equals -5. If I plug that into our function, -5 squared over 2 plus -5 plus 1, I get 8.5. So the height of this first rectangle is 8.5 with a base of 2. Is a total area of 17. Okay, then I just keep doing that for each rectangle. So this next one, between -3 and -1, height from the left would be height at -3. Plug in -3, you get 2.5. So 2.5 times 2 is an area of 5.
Okay.
Cool.
Thank
this,
you.
no problem. So if this next one, I'm doing 4 right-endpoint rectangles. So I'm going to do the same thing for the start. My change in x will tell me what the bases of each of these rectangles are, is b minus a over n, is 8 again, that's 3 minus -5, over 4 is 2. So I still have a change in x of 2 units. But because we're doing a right-hand Riemann sum this time, we want our heights to come from the right-hand side. So this base is still 2, from -5 to 3. But my height is going to come from the right-hand side, which is my height at -3, is 2.5 for my first rectangle. So here, I have 2 times 2.5 for my first rectangle, is an area of 5. Okay, then an area of 1, an area of 5, and an area of 17. And if we add them all together, that gives us 11 plus 17 is 28 again. Any questions on the right-hand Riemann sum? Okay, the hard one. I want the midpoint Riemann sum. Again, with 4 rectangles. So you can see graphically, instead of taking my height from the left side or the right side, I'm taking my height from the middle. So my first rectangle will be from -5 to -3. And if I want my height from the middle, then my height would be 5. So there's my 4 rectangles there. And my heights are going to come from the middle. Okay, so for a midpoint Riemann sum, this is 2 times my y value at 4, which is 5. 2 times 5. 2 times 1, 2 times 0, and 2 times 5. And if we add them all together, that's 10 plus 2 plus 0 plus 10 is 22. Okay, and then lastly, if I want to make trapezoids, then I'll be using both heights instead of just one height. So again, my change in x is b minus a over n is 8 over 4, or 2. So my trapezoid looks like this. Okay, where I've got these heights at 8.5 and 2.5 for my first one. So that's a base of 2 with heights of 8.5 and 2.5, which will average to 11 divided by 2. Or 5.5 times 2 is 11. So again, that's area of a trapezoid is base times h1 plus h2 over 2 is what I'm doing for all of these trapezoids. Okay, for the second trapezoid, I'll take my height at -3, which is 2.5, and my height at -1, which is 0.5, and average those together. So that's 3 divided by 2 is 1.5, and then multiply by my base. 1.5 times 2 is 3. Okay, so when I do this for all 4 of these trapezoids and add them together, I get 28. Any questions on anything? Okay. So I have a handful of questions for us to try for homework that I've sent through WeChat and Skype. And I will post a course site link shortly. If you guys have questions while you're working through it, just let me know on WeChat and I'll get to you when I can. Before we break, we do have a schedule change that affects all of our classes starting next week. So you should have received messages from Mr. Jamal this morning for a handful of videos explaining why all the changes are coming into effect. But basically, we're trying to limit the time that everybody's spending looking at the computer screen, so our blocks are changing from potentially an hour and a half to everyone has to shorten their classes to only 1 hour. However, to make up for that, all of your classes are going to be doing live sessions similar to this. So either through Zoom or through Skype. All of your classes should be video conferencing. For the math department, they've told us...
Are we sticking with Skype?
I will put it to vote. If you guys feel like the connection's better over at Zoom, then I can try to get a Zoom license and work over there. But I feel like Skype has been working out okay for us. Let's see, how many people do I have right now? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's vote right now then. If you guys
I'm
want...
okay with Skype.
Okay. So I've got Nikita, that's 1 for Skype.
Skype.
Okay, oops. Can't show that. Okay, Skype for Nikita and Abby. I guess this isn't really fair because I've got a handful of people that are not here. Okay, Okay, I think this is going to be faster and a little bit more fair if we just post their votes into the WeChat group. So I'll do it that way. Please vote whether to stay with Skype for video conferencing or to move to Zoom. Okay, so if everyone can post in the WeChat group really quick. Okay, while they're doing that, so this block is block 4. So we will be hosting next week starting at 1 o'clock instead of at 2 o'clock like we've been doing. And other than that, everything's going to stay pretty much the same.
Are we starting at like 1:05? Not 1. 1 is like passing time.
I can do that if you want. So if you want to break between your classes, so we can start at 1:05. Okay, what have we got here? I've got 3 for Zoom and 4 for Skype so far. I've tried out Zoom. It's pretty much the same as Skype, where we can video conference and share a screen. I'm more concerned with your connections than anything else, because I feel like I can do everything we've been doing with Skype on Zoom, or vice versa. I can do everything with Zoom on Skype.
Yeah, I just had like connection issues with Zoom, so I don't think it's good.
Okay. I've had connection issues with both now. I'm trying it out with my other classes. So. Okay, so I'm going to leave that poll open until midnight tonight, and then whichever has the most votes, I'll go with that. Either way, I'm going to still record my screen the whole time and post recordings, so if there is connection issues, either on Skype or Zoom or whatever we end up using, you guys will still have a recording.
Okay.
Alright, thank you very much for coming, and have a good weekend.
Thank you.
Bye.
Thank
Bye.
you.